This is a required practical for the energy changes topic, AQA board anyway, and the reaction is between sodium hydroxide, which is of course an alkali, so sodium hydroxide solution, and hydrochloric acid solution, and you get sodium chloride water. So you've got NaOH, an aqueous solution, HCl, dilute aqueous solution, gives you sodium chloride solution, and you form a little bit more water. Obviously there's already a lot of water there for the dilute solutions. Okay, and that's exothermic. So what happens is the temperature of the solutions is going to rise because the chemical energy is going to be converted into from the chemical energy store into the thermal energy store. So you can see the chemical energy of the products is going to be lower than that of the starting materials, the reactants. Okay, so how is this done? Right, so you are given a solution of sodium hydroxide and you place that in a polystyrene beaker. Okay, and that's because polystyrene is a good insulator, so any heat changes stay hopefully in the beaker and not just lost to the environment. You measure out your 30 centimeters cubed of NaOH with a measuring cylinder, and then you take the temperature. And I've written the first result in there, so I'm saying it's 18 degrees C. That would be the sort of temperature you'd normally get if you get a bottle from in a lab. And then what you do is you add 5 centimeters cubed of hydrochloric acid, and then you give it a little stir with the thermometer. That's supposed to be a thermometer in the polystyrene beaker, and the temperature should rise. I don't know what it will rise to. Let's say it rises to 19 degrees C. Okay, and then you add another 5, so then you've added a total of 10, and you keep on adding 5 centimeters cubed of hydrochloric acid every time until you've added a total of 40 centimeters cubed of HCl, and that's it. Okay, so then what you need to do is plot your results on a graph shown below. Okay, so you get something like this. So I'm going to be adding, so you get, that's the starting one, about 18, and it gradually goes up. And then this happens. Right, now first of all, you're not getting a huge temperature rise here. So if that's 15 degrees C, that would be 20, 25. So you're only going to get small rises every time. So if you look at that line, the line, it'd be quite hard to draw a line of, well, you can draw a line of best fit, but a lot of the points actually aren't on it because you're measuring like differences of 1 degree C, which is not that great. So it asks you to plot 2 lines. It asks you to plot this one line like that. Okay, and that's going up. And then you plot another line, the one that's where it's going down, like that. Okay, now we need to think about what's happening there. Why does it go up and then it goes down? Right, the green line, the temperature is rising there, and that's fairly easy to explain, and that's because you're getting, it's an exothermic reaction. So chemical energy is being converted to heat energy, and that's making the solution warmer. Obviously there, what's happening is the NaOH is reacting with the hydrochloric acid. Now, why does the temperature drop for this blue line? Now, the temperature drops to the blue line is because what we're saying there is at this point, all of the NaOH has been used up. So when you add extra HCl, no further reaction occurs. And of course, this HCl that you're adding is a little bit cooler. It's got a slightly lower temperature than the reaction the reaction mixture in the beaker. So when you're adding this HCl solution, you're not getting any more reactions, so you're not getting any more heat energy. And the amount of heat energy in the beaker stays the same, but it's been diluted out in a greater volume of hydrochloric acid. So what you can say there is, and they ask you to draw this line at this point, and you extrapolate it. So you extrapolated a line there at 30 centimeters cubed. That's where you've added enough HCl to neutralize all of the NaOH. And if you add any more after that, then you're just diluting the heat out. So the temperature will actually go down rather than going up. Just important to note there's no endothermic reaction going on here when the temperature goes down. This amount of heat energy stays the same. It's just spread out more because you're increasing the volume of the solution. So that's the required practical. It's a little bit of a funny one, but I think they've definitely asked an exam question on that before. I think it might be in the specimen papers, or it might actually be one of the real exams. So obviously they're quite keen on it.